Hello everyone, how's it going? My name is Dan the Tutor. Today we are going to be talking about sine and cosine functions, specifically graphing them along with the amplitude and the period and the phase shift and all that good stuff. So let's first start off with the equation for any sine or cosine graph. A sine of parenthesis, B second parenthesis, x plus c, close parenthesis, plus d. And we're going to be talking about all four of these things. They all mean different things. And by the way, if you want the cosine, it's the exact same thing, except cosine starts at a different value than sine. But it looks identical. So let's talk about what all of these variables mean. A is going to be our amplitude. That's how high or low the graph goes from the middle point. So for instance, if I have a graph that looks something like this for a sine or cosine, and the peak point here is 5, well then the amplitude is 5. Even though it goes down to -5 and it covers a span of 10 up and down, in other words, if you count the tick marks from -5 to +5, that's 10 tick marks, we would still say the amplitude is 5. And that's because of how we measure amplitude. You always measure from the center. So basically that means if I have a more complicated example like this, and we go up and down from, let's say, top 4, bottom 0, well, the middle line here is 2, because between 0 and 4 is 2, and the amplitude would therefore only be the distance from the middle to the top. That distance is 2, so the amplitude would also be 2. So that's how we measure amplitude, from the center line, so be careful. The next letter we need to talk about is this letter B right here. B is often called, I've heard different things over the years. One name for it is a wave number. Another name is an angular frequency, but that's usually the physics definition. So whatever your teacher calls it, that's what I'd recommend doing. But really what B is, the wave number, it helps you find the period using this equation. B equals 2 pi over t, where t is our period. And the period is the thing that we can actually see in a graph. So as a quick example, let's say I have this graph that looks like this, and I know that the distance for one oscillation, because that's what a period is, time for one full oscillation. What's an oscillation? That's when the graph goes up and down and back to where it started. So in other words, if I start here at 0 and I go to this point right here, which is one full oscillation, as you can see, and let's say that distance is 2 or time 2, well then that means my period for this wave is going to be 2. By the way, I can measure from any 2 points. I'm saying the distance from here to here, since it's the same point at the top, that would also be 2. And if I looked at the bottom, like right here, this distance is also 2, because it's 2 for any point that is the same. The period is the same no matter where you measure it. And so what that means is if I want to find B, which B actually goes in the equation, but we can see period on the graph. So basically B, that goes in the equation, and the T, which we just said was 2, that comes from the graph. And then the 2's cancel, and you'll get B equals pi. So that's what would go in that equation, the sine equation for the B. You'd put a pi there. So then that's it for B. Next we want to talk about C. C a lot of times is the hardest one to find. It's the horizontal shift. In other words, shifting left and right. Now the one thing you got to be careful for is that the horizontal shift goes in the opposite direction as the sine, plus or minus. Let me show you what I mean. So if you have the sine of x plus 5, for instance, then that should be a shift 5 to the right because it's positive. Except with horizontal shifts, it's always the opposite. This would actually be a shift of 5 to the left because it's the opposite. If I had the sine of x minus 5, well now that's a shift 5 to the right. So it's just the opposite. That's why for a lot of times in the equation, you don't see x plus c. A lot of times they write it x minus c. And it's basically the same idea. Whatever direction you think it is, it's the opposite direction. So actually, a lot of you out there probably do use minus in the equation. So just to be consistent with what your teachers are doing, I'll put a minus there. But it's the same idea. And so what that looks like is, let's say I have a graph that looks like this, okay? And then after I shift it, the graph now looks like this. And you'll notice it's off slightly. And the reason why it's off is because, well, first if I give us a period, like let's say that's 2 pi right there. And all the points here are consistent, meaning that if I were to take a dashed line, all these points do match up. We basically took the entire graph, which I can grab right here. We basically took the entire graph and moved it from here and moved it that much over. You see that? I moved it from here and moved it that much over. How much is that? Well, I'll tell you. In this case, we moved it a quarter of a period, 1/4 t. We moved it 1/4 t to the left. How do I know it was 1/4? Well, basically, I moved the peak, which is right here. I moved the peak from here to here. And if this is half a period right here, this is a quarter of a period. Now, if the whole period was 2 pi, because I said so, that's one oscillation is 2 pi, then a quarter of a period is 1/4 times 2 pi, which reduces to pi over 2. So it's a shift of pi over 2 to the left. That means my equation would, for instance, look like sine of x plus pi over 2, because the shift to the left means that I do want to add the number. So plus pi over 2. Which means c is negative pi over 2. And why is that negative pi over 2? It's because the equation is x minus c in the parentheses, and you get a double negative, making it positive pi over 2. So c is negative, but it's still a shift to the left. This can get really confusing. The only way you're going to get better is with more practice problems. And then the last thing to talk about before we look at some practice questions is D. D is one of the easier things. It's just the vertical shift. It's just how much you're moving the graph up or down. And unlike the horizontal shift where you have to do the opposite, if you have +2, the shift is up. It's the direction you expect it to go. So now if this is my graph, and normally sine, for instance, is centered at the 0, but if I shift it so now that my midline right there is at, let's say, 4, and the graph looks like this, well, then my equation is sine of whatever, and then plus 4. So the vertical shift is one of the easier things. It's just the distance of the center line. Okay, and that's going to do it for all 4 parts of the sine and cosine equations. Now let's look at some examples. I guess before we look at examples, we need to know what a normal sine and cosine graph looks like. Sine normally looks like this. This is just sine x. You'll notice it starts at 0, starts at the point 0, 0, and the period is 2 pi. So t equals 2 pi. That's true for any normal sine graph. And then cosine looks almost identical to it, except cosine starts right here. So this is cosine x. And you'll notice that cosine x starts at the point 0 for x, 1 for y. You start at 0, 1. But the period, which is this distance right here, because that's one full oscillation, is still 2 pi. 2 pi is the normal period for any sine or cosine function that's just normal. And the reason for that is we did follow the formula. What's the formula? Well, b equals 2 pi over t. And if you look at this equation, I know you don't see it, but b is just 1. It's an invisible 1 in there in the equation. So then 1 equals 2 pi over t. Multiply by t. T times 1 equals 2 pi. Divide by 1. T equals 2 pi. There, we just proved it. Now, you don't have to prove it every time, but this was a good example. But all you need to know is that the period of any sine or cosine is 2 pi. Okay, now let's look at some harder examples. Let's say I have the graph of 3 cosine of pi x. So if I wanted to start graphing this, the first thing I would do is I know it's going to look like cosine. What do I mean by that? Well, it's going to look like this. Like, I don't even have to know anything about this function except for the cosine, and I know it's going to have generally this shape. I also know, since the amplitude is 3, that the highest point is going to be 3, and the lowest point is going to be -3. Now the only thing I don't know right now is the period, which is the distance from here to right here. So if I want to know that distance, I'm going to say b equals 2 pi over t, and the b is the thing in front of the x. It's always the thing in front of the x. So in this case, it's pi. So that means pi equals 2 pi over t. Multiply both sides by t. T times pi equals 2 pi. Then we just divide by pi. T equals 2 pi over pi. The pi's cancel, and the period is 2. That means a 2 is going right there for one full period. It also means if you want to find the other points here, because there's always 5 main points on a sine or cosine graph that we care about, I will draw them right now. Here, 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 and here. That's because it's either the highest point, lowest point, or a 0. If you know those 5 points, you can graph any sine or cosine. Now basically, since I know one full oscillation's 2, if I want to find the distance of all the other ones, I like to say cut in half twice. So what does that mean? If I cut it in half once, I get this point right here, which is 1. And if I cut it in half again, I get this point right here, which would be 1/2. And then if I want to find this last point here, what I like to do is I just like to start counting. What do I mean? Well, the first tick mark is 1/2. That means the next tick mark is 2/2. Now, 2/2 of course reduces to 1, but it's 2/2. The next point is 3/2, which will be the point that I'm missing. And then the last point here is 4/2, which is also 2. So basically, if you want to start finding the other tick marks for the 5 most important points, cut in half twice, and then start counting. And we'll do that again and again in the next few problems. But this is the graph for 3 cosine of pi x. Excellent. Now let's look at another one. Let's say I have the sine of 2 times the quantity x plus pi, close parenthesis, minus 1. So here I've got 3 things going on. Number 1, I've got my b, which is going to affect the period. Number 2, I have my c, which is going to be a horizontal shift, also known as a phase shift, if you know physics. And that's going to be a shift of pi to the left, because it's plus. And then that right there, d, that's a shift of 1 down. So let's go into more detail. How does b affect the equation? Well, b equals 2 pi over t. I want to find the period. That means 2 equals 2 pi over t. Multiply both sides by t. T times 2 equals 2 pi. Then divide by 2. T equals 2 pi over 2. 2's cancel, and I get t equals pi. The period is pi. Now for c, the horizontal shift, that's going to be a shift of just pi to the left, and that's because it's plus pi, so it's a shift of pi to the left. And then the d, the minus 1, that's going to be a shift of 1 unit down. And there we go. That's everything I need to know for the graph. It's also sine, which means I'm going to start at 0, 0. So the first thing I'm going to do is I'm going to graph a normal sine graph just to show you what it looks like. So here's the normal sine graph. Now again, that period right here, because that's one full oscillation, is 2 pi. And I really care about the 5 most important points, which are the 5 points in red, because as long as I have those 5 points, I can graph any sine graph. So basically, when I start talking about the changes that's going on with this graph, well, the first thing, what do I do first? Because there's 3 things I'm changing. You can start in any order you want, but you have to do all 3. Let's start with the C and the D, the shifts, okay? So I'm going to take my red dot from 0, 0, and I'm going to move it 1 down and then pi to the left. Now, how much is pi to the left? I don't know, but let's say it's right there, for instance, okay? So basically there's -1 and there's negative pi because I shifted it down 1 and I shifted it to the left pi. Now keep in mind, this -1 will be our center line, okay? So I'm going to put that dotted line there now because I know it's going to go up and down around that center line. And then I know one full period is pi. Well, here's negative pi and here's 0. That distance is pi. That distance is one full period. So we go back to where we started right there. In other words, a full oscillation is going to look like this. So that's what my sine curve looks like. Actually, if you think about it, my amplitude's wrong because my amplitude is 1 because there's nothing in front of the sine. Amplitude's 1, which means it actually goes 1 higher. So it is going to make it back to 0. So let me make it a little higher like this. Okay, that's better. And again, here are the 5 points that I have. If you want, you can label them. It honestly doesn't matter. But basically every pi, in other words, this pi, the 2 pi, the 3 pi, and etc., that's where you're going to go one full oscillation. So if I were to graph this for one full oscillation for all of these, it's going to look like that for the first one, then that for the second one, then that for the third one. And again, because every one of these is one full oscillation, it's 1 pi, and this is what the graph will look like. So if you got confused in any part of that explanation, which I'm sure you did, just restart the problem from the beginning. I explain every step. I'm not saying I'm perfect because I know this stuff is hard. But I am saying is that if you do enough practice problems and you spend enough time at it, you will get it. I promise. And then let's do one more. This will be the final boss. Let's say I have 2 cosine of 2 pi x minus pi and then plus 5. So this one's got everything. It's got an amplitude, it's got the b, which is going to change the period, it's got a horizontal shift, and it's got a vertical shift. We have everything here. The other thing that's different is you'll notice I didn't put the x in parentheses this time, which actually means the first thing I need to do here is I need to rewrite what's inside the parentheses. I need to write it like 2 pi times x minus c. And why 2 pi? Because I'm factoring out a 2 pi. Now if you want to factor out 2 pi, all you do is divide both of these, this by 2 pi, and then you divide this by 2 pi. And you'll notice that the 2 pi's cancel here, leaving you with x, and then c, well, the pi's cancel, and that leaves you with minus 1/2. So this is what the graph really looks like. 2 cosine of 2 pi quantity x minus 1/2, close parenthesis, plus 5. And again, the reason why I did this is because I need it to look like this because now we're in the form b of x minus c. And again, what did I do? I factored out the term next to the x. It's not always going to be 2 pi that you pull out, but it will always be the thing next to the x, which means if I have the cosine of 6 pi x plus 1, well then I'm pulling out a 6 pi, and then what's left? Well, if I divide both of these by 6 pi, I'm left with x plus 1 over 6 pi. And that's how you do that. But I'm not talking about this example, I'm just showing you what it would be. So basically A, our amplitude is 2, B, I call it wave number, is going to be 2 pi, C, our horizontal shift is going to be 1/2 to the right, because it's minus, so I'll write to the right. And then D is going to be 5, and that's a shift upwards, because that's just normal. Okay, so if I want to graph this, again it's cosine, so normally cosine will look like this. Okay, where we've got 2 points of interest here. I know there's 5, but I only need the 0 and the 2 pi because that's the period. And now I'm going to talk about the shift. So first, it's a shift of 1/2 to the right and 5 up. So I'm going to move that point right there in red. I'm going to move it 1/2 to the right and 5 up. So let's say here's 1/2, and let's say this is 5. And so there, I'll just put the point right there. Well, actually, hold on a second. The vertical shift doesn't move my point 5 up. It moves the center line 5 up. So in other words, my center line is at 5, and my point here, well, that is the amplitude. So what do I mean? It means I have to find the peak point by adding the amplitude, which is 2, to my 5 up. So what am I saying? I'm saying the highest point is actually way up here. It's 7, because 5, my middle line, plus my amplitude 2 is 7. So that's my first point. Actually, I missed, because I was supposed to draw it on the 1/2. So here's my first point. Okay, now let's find the period. So the period b equals 2 pi. That means b equals 2 pi over t. That means 2 pi equals 2 pi over t. Multiply both sides by t, and then we divide by 2 pi. So it looks like t equals 2 pi over 2 pi, which is just 1. My period is 1. In other words, I am going to make a full period by 1 right there. Well, actually, that's wrong. 1 plus 1/2. Because I'm starting at 1/2 now. So then what's 1 plus 1/2? Well, that's 3/2. So what I'm saying is the distance from 1/2 to 3/2, that distance is 1, my period is 1. That's where I'm going to complete one full oscillation. I also know that the lowest point's going to be down here, it's 3. And the lowest point's going to be right here for the cosine, because for cosine it's the very center. Okay, and before I start graphing this, I do want to just map out the next few. Like for instance, that was 1/2, here's 3/2. The next one's going to be 5/2 for a full period, then 7/2. So each of these points, 5/2, 7/2, 9/2, all of those are going to be these red dots at the top, the starting points. And then if I cut in half, that's going to get me these points. And then every point in between those, if you were to imagine drawing a straight line between them, that's where my 0 points are going to be. And if this doesn't make sense why I'm doing this, remember, a period is one full oscillation. This is one full oscillation, and we said the period was 1. And then the cosine and the sine follow the same 5 points every time. For instance, for cosine, it starts high, then 0, then low, then 0, then high, and then it repeats that forever. And this is what my graph is going to look like in this curvy roller coaster kind of shape. And this is what the graph is going to look like. And that's basically it. I know I can get into a lot more detail with these questions, but this is a good introduction. I know it's complicated. We looked at some hard examples today. But if you just keep at it and keep on doing practice problems that your teacher gives you or you find online, you're going to be fine. But you gotta keep trying and not give up. So thank you all for watching this video. If you have any questions, please post them in the comments below. Have a great rest of your day. Take care, and bye-bye.